data that, let's say, is distributed. It's not centralized, it's not stored in a cloud. Some guys figured out that the Web3 or attached to the Web3 buzzword, the punchline that Web2 was read-write and Web3 is read-write-own. So the ownership of the data is an important part of everything. We think that the way we treat data will change long term. Obviously, we are big, and right now we are witnessing the Bitcoin swings and everything, but there will be also some technology appearing out of this. And I will make a weak analogy, so it's not a powerful and not a one-to-one, but somewhat to try to explain what I mean by that. Okay. Where it is? Sorry, I'm a bit lost in this. I'm not a macOS user, but I'll get used to it. Okay, I hope you'll see what I see. Okay, so if you remember, 15 years ago, there was HTTP all over the place. You could just launch a TCP dump and see what your colleagues were chatting on Yahoo Messenger and so on. So the solution to that problem was HTTPS. Right now we are so accustomed to this, so you also, I hope we see the same thing. On the bottom left on my screen you see a snapshot from a browser and a small lock that is attached to the URL. Nowadays we only trigger if we don't see the lock or if we see a red sign there. So we got so used to see trusted communications on the HTTP layer that we don't even care about it. We believe that something like that will happen with the data long term. So what HTTPS is solving for is the identity or proving the identity or preventing tampering or faking the identity of the remote node and the communication. So it also has encryption in transit. Now, it took HTTPS like 25 years to get here, but it happened. And we believe the same will happen for data. Like in 2000, you got payment sites that were using HTTPS, and that was about it. I mean, it was both expensive in terms of compute. You needed additional resources, you needed certificates, which are even now, unless you use Let's Encrypt, are quite expensive, and so on. So there is a big overhead of it. Then we had 2010. If you remember that period, there was full of spoofed Facebook pages, getting you to click, to earn, to whatever. So that, another revolution happened when the social media figured out that the identity needs to be protected and switched to HTTPS. Obviously, then there was Snowden, when we found out that everyone is spying on everyone, and HTTPS traffic was dumped not just by country actors, but also by every ISP, every network provider was spying on what people was doing. And right now we are at the point where there is a high adoption. And what we see is that painkillers, or let's say problems from the past, become regulatory requirements. Right now you have to have HTTPS if you are transferring sensitive data over HTTP. And we already see that this is happening also, so the regulation is starting. Last year there was an executive order issued by the US government that was saying just that every data needs to have immutability proofs. And the way to do it is with hashing. Now, why we believe that Web3 data is revolutionary, or it's changing the approach? I mean, the tech already exists, or there are various approaches. What will happen is a generalization of it. The first step to the revolution of getting to Web3 data is the ownership. So instead of us giving the data to Google, which monetize the data, it will be us who own the data and get a part of the revenues associated with it. Then there is the immutability proof, and if you think about it, like A Git repo, for example, it's already, if you have the rewrite history disabled, it's already an immutable ledger by authority. Bitcoin is the first immutable ledger achieved via a distributed consensus. So we think that the immutability proof, or some kind of immutability, because it depends how far you go with the guarantees you need, you will have to drop some of them. Or depending what guarantees you have, you will have to set up, or there is no perfect world, so there is a trilemma also in here. What I want to say is that existing data will, especially sensitive data, will have to have some immutability proofs. And what we try to build is a solution that makes that very easy for anyone to achieve. Okay, there is, in addition to this, there is lineage. If you think about cryptocurrency, all the transactions have full lineage. Like, you can see that a payment came from another account which had the sums from another account. Of course, if the cryptocurrency is not designed to obfuscate that, like Monero. So there is some history that you can trace back. If you think about the Ethereum virtual machine, it's a distributed virtual machine which computes some states for the smart contracts. You can get a full lineage of how the state of that smart contract was achieved. And again, with the parallel, so this is what we mean by Web3 lineage. In addition to the data lineage, there is also computational lineage, and I'll get back to it a bit later in the process. So this is the security dimension of the Web3 data. The second dimension is value, because Web3 comes with built-in monetization. You can build various tokenomics models, like people that write data get some tokens, people that read data pay some tokens, and some trickle-down economics in the middle of it. We also believe in the confidential computing part, meaning that in order to add value to data, you need to be able to compute on data that you are not able to see. And the on-chain egress of data on apps or distributed apps on-chain. And where Weavechain comes into play is we try to build solutions that are compliant. There are existing solutions for Web3 data, like IPFS, Ceramic, but all these are not compliant. For example, if you put something on IPFS, it's there forever, you cannot erase any record from there, so the GDPR compliance is gone. Also, for HIPAA compliance, if you store medical records, you need to have a physical safeguard, and that cannot be achieved with existing solutions. Then there are the private Web3, which, if you are familiar or not, Corda, Hyperledger, there are several solutions, which require replacing everything you have with their built-in technology. Now, this was, let's say, the pitch. Now, back to the workshop. We will try to, I thought about it before getting here, like 2 weeks ago, to start build something with you or to go through some predefined flow, and I got to the conclusion that it's better that I, let's say, present you ideas better than coding, because I could not teach you to write Solidity code or use Foundry or whatever better than any existing website would teach you. So there is no point to do that. So I think it's more about ideas than tools. We will inevitably do something and use some tools, but it's more like it's not actual coding. If we want to do actual coding, it will be next time. So what we'll try to do in this workshop is to leverage Web3 tools and to show how we can achieve some kind of data economy. We'll start by minting a PO app or an NFT. How many of you own an NFT? Nobody owns an NFT? Cool. It will be fun then. So we will start by minting an NFT. Owning that NFT will give us access to a data. We will be able to read some data, write, launch some compute, just because we own that NFT. And we will show how we achieve the immutability and lineage properties, and also some built-in monetization. Now, in the first part of the workshop, we'll do let's say, a centralized approach. Like, I prepared the website, and we will go through the steps to run something that is, let's say, a predefined flow that will get us to write data in a data broker. We establish a data economy where somebody is holding our data. And we will get some tokens in exchange of storing some data in the data broker, and then that data broker can sell the data further on. In the second half, we will try to get to the ideal stack, which is the ideal stack is each one of us owning his own data, running a node that connects to his local storage, and making the data available to a distributed network. And there is more on the, I'll skip the immutability part. Okay, the first step is to get the NFT. I will give you some near-field communication tags, so it's some NFCs. There was no need for it, but actually it was meant to be sticked on a Kodiak sticker, which the print shop did not deliver, unfortunately. So you will have some raw NFC cards, which you can reprogram afterwards. If you scan them with the phone, you will be redirected to a link where you can mint your POAP. POAP is a proof of attendance protocol. It's some kind of protocol on chain that is used to, let's say, get some badges. Not hubris was the right word. Reputation badge or something that you have on chain. With that POAP, we then will be able to log in the website that I created. There is one thing here. You can mint POAPs, or you can use MetaMask on a mobile device only if you have the MetaMask browser. If this is too complicated, maybe you should register with the email, or you scan the tag, then you use the URL on your browser. It's a bit of a problem there. Also, when you mint, so in order to mint an NFT or to do anything on chain, usually there is a transaction fee. We will do it on Gnosis. Gnosis is a blockchain that has no fees for this particular operation. And there is also my colleague here which can help you on setting this up. The first step is to connect your browser to install a MetaMask plugin, connect it to the Gnosis blockchain, and mint a POAP. And I will give those around, and please pass them. Another point I wanted to make with the stickers, unfortunately, as I said, there are no stickers because the print shop did not deliver, was that the physical stickers, probably you will lose them or you will throw them in a bin, while the POAP or the NFT is on the blockchain immutable, is for forever. So it's okay. So for this first step, please let me know if you are able. Or obviously, you don't have to do the flow if you don't want to. Don't worry. So once you scan the tag, you will be redirected to, there is a POAP allocator. In real life usages, theoretically, the unique ID would have been coded on the NFC tag, but it would have taken too much for me to write them with unique ID, so there is an allocator behind it. Obviously, this NFT gating is just one way of gating the data. You could just as well use the classic private public key approach, or verifiable credentials, which is another, let's say, hype in the. Actually, the World Wide Web Consortium made a recommendation this year to transition to verifiable credentials, which could mean in the long term the death of the passwords, at least in a corporate environment, or when there is a trusted ID server. And if you want to write your own web page on the NFC after this workshop, there is an NFC tools on App Store, and you can easily write anything on it. Is anyone having problems, or if you need help, please let me know, or let my colleague know. Anyone not being able to do it? Okay. Authenticating took longer than expected. Are you able to see the read data button, or somebody was able to get to the read data button in the app? Any feedback? Yeah? Okay, so you should all get to a point where you see a read data button in the CodeX app. If not, please let me know to help you to get there. Okay, so the first, I already prepared a table for which I set some columns that are visible to the outside world and some columns that are private, meaning that they are written in the data broker, but when somebody reads, those columns will be obfuscated. And there are several ways to go about it. I set up erasure for some columns and some random ID for the wallet. So these are ways in which you allow people to read a part of your data without obfuscating certain columns from the data. If you click read, please raise your hands if you were able to see a list of people. 2 people only? 3, 4? Okay. So that's all? You need help? Okay, hopefully you see the read button, and if you click next after the read button, you will get to a screen where you can write your own detail. Please fill whatever you are comfortable there and hit the right button whenever you can. Just change the email and maybe the birthday. If you want to enter the full data, feel free. If not, and please let me know if there are people that were able to cross the right barrier. So after you write the data, we'll continue with the flow. Also, please, if possible, open the developer console. So you have the developer console for the JavaScript console log to see some stuff there, and we'll talk about the compute lineage. Actually, not the data lineage first. Okay, so I saw that many of you were able to issue the write. If you check your console log in the right, you will see a lot of mambo jumbo. So I printed here some examples. What happened behind the scenes is that your JavaScript API in this browser, it can be the Python, Java, R or whatever API behind, signed the data. It computed a hash of the data, and then using EDDCA, if you are familiar with it, it signed the hash of the data with the client signature, so your API signature. This data then goes to the data broker. There could be a larger trust network, so it's a distributed system to store the data. And the data gets replicated between multiple nodes. Now, when each node receives the data, recomputes the hash, checks the client signature, and by this way, it's making sure that the data that is ending up in the storage matches what the initiator wanted. This is the first step of proving the data immutability. Or this is actually just verifying that the data that gets stored in the trust network matches the writer's purpose or what the writer wanted. The second step is the nodes compute a signed hash or a salted hash of the data. This is needed because otherwise, because there are small records, theoretically you could have a dictionary attack against the hashes. So the network recomputes a hash using also a secret key, which is known only to the storage network. And that hash ends up on a blockchain to prove the immutability. Now, in order to prevent malicious nodes writing, let's say, the writing on the blockchain happens only once. How do you make sure that the data that gets written on the blockchain is not faked by the node that does the actual write? And the solution to this is to use a threshold multisig signature, meaning that there is a private key that is shared among multiple people, and there is a combined signature that has a threshold, meaning that at least 2/3 of the network need to sign their private signatures combined and can be checked with the public key of the network. And this hash is written to the blockchain, and the smart contract on the blockchain can check this using the public key of the network and make sure that the hash is indeed vouched by the entire network. So in this way, you have this immutability starting from the data producer up to the blockchain. Yeah, so the long story short is that you get some hash written on the blockchain and some stuff happens behind the scenes to prove the data is immutable and conform with the writer's intent. There is also a hashes contract, smart contract. Maybe some of you clicked on it and saw it. So the hash gets written. Also, if you scroll right to that table, you will see the hash displayed somewhere. The hash gets written to the blockchain, and you can also see it on Polygon after a while. Now, another thing that happened, if you go to the next step in the page, is monetization. I've set up some fees. There is a sample of the API above there. So you get one USDC fake or whatever, test USDC on Polygon testnet every time you write some record. If you check your balance, you should see that balance, and you should also see a bridge contract that it's synchronizing periodic. The whole idea is that payments are expensive on blockchains. Data sharing agreement networks could have micropayments that set up their own economy, and there could be fees on the number of writes or the volume of writes or the number of compute seconds spent by each one, or the writer could pay or the writer could receive money. It's up to the people that design the tokenomics of the data sharing agreement. The micropayments happen in an internal ledger, in a custodian ledger, which then gets synchronized to a blockchain that holds the real supply of the token. If you go next to the next step in the website, I wanted to show how easy it is to trigger a compute on the data. This is the API for multi-party computing. We support 3 patterns of confidential compute. Actually, it's a bit too much of a pitch. I should get back to. There are 3 ways in which you can extract data out, a value out of data without seeing it. One of it is multi-party computing. In this website, at this step, we showcase the degenerated form, which is one-to-one. But just as well, it will work in multi-party, and I don't know if we have time in the second part of the workshop. I wanted to go get there where we run multi-party computing with the data stored on our machines. There are those patterns of confidential compute. One is the multi-party computing, which means that one consumer gets to run some data on multiple owners' machines without seeing the data and without the owners learning anything about the data. So basically, let's say in this sample, we could compute the average age of everyone here without anyone seeing the age of anyone else, because it's stored locally on their machine. For this, we use the SPIDS or SPDZ protocol. It's developed by Alexandra Institute, Damgard. If you know the guy from SAJ, checksum. Another pattern of compute is the compute data. The compute data is when the owner of the data runs an algo on behalf of the consumer and generates the results and provides the aggregated results to the end user. This is suitable in cases when the code is not secret. So the algo that I'm running is not secret and can be shared with the data owner. And I wanted to showcase here the compute lineage, what we call compute lineage. You already saw that we have some hashes on the blockchain that proves immutability. If you enter that data in some calculations, you have some immutability proofs and you have a hash of the input data, or you can compute a hash of the hashes. So you have a proof of the input data. Then you have the hash of the Docker image, and then you have a hash of the output model. In this case, if you trigger compute data from the website, it will actually launch a machine learning model on our server. Hopefully it stands because it's not such a powerful machine. It's generating some machine learning model, and it returns it as a base 64 encrypted blob, which can then be used. If you click on the Jupyter notebook, you will get to the Python API, where you can see also how this is triggered, how the model is used, and the verification of the signature. So by compute lineage, we mean the node that performs the computation computes a signature on these hashes and links them together, meaning that for certain input, certain compute, and certain output, you have a signature, a node vouching for the output. This can come, from accounting ledger to reconciliations between brokers and traders. There are multiple use cases for this part. We also believe that long-term this will become quite prevalent, including for machine learning models that have to prove the lineage of their data, that they are not biased, and so on. Taking this a step further, like in the scenario when there are multiple nodes replicating, so suppose you have Toyota, Hyundai, BMW sharing some data, and each one of them can launch the compute task and have the signatures, and you can have a consensus of the compute. And we think that this addresses the replicability crisis in science. Let's say it's a deeper problem, it's the human factor more than anything, but the compute part of the replicability crisis is solved by the consensus on compute and lineage. And hopefully you were able to go through these steps in the website. If not, please let me know. And what I wanted to do in the second part of the workshop, but we won't be able to do it because half an hour, this one is more tricky than the first part, is to build a data sharing agreement here where we run some nodes on our laptops and share the data. We share the data without sharing the data, without storing them in a data broker. I think, so if you want to go through it, you have the instructions here, and you can also contact me offline. I think we won't have time to do it now. It would mean installing some Dockers. It's running a node image and running a Jupyter server. The Jupyter server is needed just in order to have an easy way to connect with the node. And the whole idea would have been to connect to the node, your local node, create some record, read then all the data from basically the previous scenario that you saw in the website, but without having a data broker, so without Weavechain holding the data. I think we should close it here, and if you have questions, it's half an hour for Q&A and relaxing, I guess. I guess at least you were able to mint an NFT. Any questions or? Yeah. I'll go to the history, so how we started with this project. So we, at some point, wanted to do, let's say, 24/7 automated time tracking using machine learning and devices and gathering data from Apple's Watch, etc. And what we ended up with was some kind of a spyware that was putting this data somewhere in some servers. And we tried to find a solution to it. And also because we kind of, let's say, tried to ride the Web3 hype a bit, we decided to implement a generic solution for this. Now, about use cases. We have several implementations. I'll start, so I have a lot of slides, but I don't, I have them hidden. I don't even know how to unhide them on MacBook. Yeah, so one use case is the clinical trials of people. Somebody is, big companies try to run clinical trials on US, and there are smaller companies that try to get people to participate in the clinical trials. And the way we do it is people publish their data, get some tokens, and, on each write, people get some tokens that transfer to the real world.
Do you have any metrics of the conversion ratios? People landing on the...
We don't do that. We are infrastructure. So our clients are in charge of building their own tokenomics. We offer them the ways to build that. So we are not implementing dApps or apps on top of it. I mentioned the clinical trials scenario. Another scenario is there are some guys that have a swap trading platform. They have the whole tick-by-tick market data, and they don't want to share it to anyone. And there we implement a combination of homomorphic encryption, because also the other guys don't want to share their algo. But homomorphic encryption is very limited. You can do only linear transformations and only transformations on encrypted values. And we combine that with something like we compute the data. You cannot take a logarithm, for example. You can compute log returns for anything. And then we combine compute data for certain tasks that then are input in the homomorphic encryption, which then the package goes to the owner of the data, and they filter the results. Like there are several ways to filter results. There is no bulletproof solution. If you have an infinite round of pinging the other party, you can exfiltrate the data. So somebody malicious could get their tick data if they want to. So you have to impose some limits. And it's another story how you do that. What else? Another scenario we have is some guys that in Japan, they added some tags in stores, and they want to get an online experience to offline shopping. Meaning that if you go in a store, you no longer have the reviews, you no longer know where to find people, things, and you no longer have the related items, which seems that it seems that people love. And the solution to this is to track their real-time movements, and again, because that is sensitive information, to use it in a confidential compute setting. don't have the installed browsers extension. This was just a demo flow for this workshop. Theoretically, the main the way our network is using different way of authentication. It can be a private public key pair, just like you do for Ethereum. But then it's a custom private key and public key, which people need to remember, need to store them. It's another headache. Authentication via wallet and authentication via NFT, which we tried here. You could also use verifiable credential, which, as I mentioned, it's an important thing we estimate in the future. And with verifiable credentials, you basically can do OAuth or anything. So if you have a trust service that's giving you the credentials, then that ID server can do any kind of authentication. So the MetaMask thing was just for this workshop, and it was to showcase the JavaScript. I mean, I thought it's easier to go to a guided flow in the first part and then a complicated flow in the second part. And the guided flow failed because it's not simple. Yeah, maybe next time. Yeah, I think this is it. Thank you for the attendance.